Hey everyone! Today I have realized I'm running short of unfinished projects, so I think it's time to start a new one. Let me explain what I need. I'm looking to make a polishing machine for my ongoing projects. There is a lot of surface polishing to do, and using an angle grinder to polish everything by hand is just too much work. Besides, the surface finish after grinder is not good enough for me in this case. I could use a big polishing machine like this one, but it's too powerful and can easily damage or break the parts. So I need something in between. Let me show you what I've got. A while ago I visited my favorite place, the scrap metal yard, and picked up some interesting stuff. The idea is to build a column. Imagine it standing upright. The column will be connected to an arm using these bearings. The arm will move up and down along the rod, driven by this old screw. At the end of the arm, I will attach a motor with a polishing pad. I will also need a worm gear and a motor to turn the screw. This whole structure will be mounted on a table or some rigid base. I know it might sound confusing now, but I promise it will all make sense as we start building. I'm planning to do this quick and dirty with no paint or unnecessary finishing touches. The plan is to build it, test it by polishing some parts. In case of success, though I have my doubts, we'll take it apart and rebuild it properly. Let's get started. And I'm starting with the rod, because everything else will be built around it. But right away I've run into a problem. You see, the diameter of this rod is 70 millimeters, but the bore in my lathe spindle is only about 50. So there is no way I can machine this rod on my small lathe. I do have a bigger one, another unfinished project, but it doesn't have a chuck. Luckily, during my last visit to my favorite place, the scrap metal yard, I found one. It's amazing what you can discover there, and it fits perfectly. However, there is another issue with the mating surfaces. Some time ago, this part of the spindle was damaged, and it seems the previous owner decided the best solution was to weld it directly to the spindle. I've tried everything, but there is no way to unscrew it. The only way to remove this part is to turn it into chips or cut it off piece by piece with a torch or an angle grinder. But I don't have a replacement part, and as you can see, this lathe is extremely old. There is no chance of finding a new one for it. Plus, machining a new part would be a pretty big side project. So I think the best approach now is to try and fit this as it is, check the run out, and then see what we can do. And things started to escalate quickly. I ran into another challenge. You see, I measured the borehole of the spindle only where I could reach, but it turned out to be narrow inside. So now I had no steady rest and no choice but to fix the rod as it is, with this ridiculous amount of run out. And I know, my dear viewer, it's very tempting to think, hey, that crazy guy on YouTube made it work, I can do that too. But please resist that temptation. Don't do this, it's about as stupid as it gets. In my case, I left the dial indicator on the part to see if it started to wobble, and if it did, I was ready to stop the machine right away. To my surprise, though, it turned out just fine, so I guess I got away with it this time. I milled, or maybe turned, honestly at this point I'm not even sure anymore. Let's just say I machined both sides, and since I was already here, for convenience, I drilled a few pilot holes for future installations. Now let's skip to the part that allows us to attach the column to a solid base. I'm starting once again with a piece of scrap metal. It's much longer than I need for this particular part, but I'm turning the outer diameter along the whole piece since I'm going to use it later for other parts. And I want to say this. I dig through scrap yards like a happy raccoon, not because I'm trying to save money, but because I genuinely enjoy it. There is something special about bringing old things back to life. For example, this arm you saw at the beginning of the video used to be a part of an Italian pantograph made decades ago. You might say it was almost dirt cheap or basically free, but keep in mind, you usually put in way more time, effort and tooling into restoring such pieces. Most of the time, it's much easier just to buy a brand new part. And when you actually do the math, considering your machine time and effort, it might even turn out more expensive than buying new. But I do it because it's fun, I just enjoy it. Otherwise, I just buy a brand new machine from China and not bother building one myself. That being said, after machining the base part, I fix it in the lathe, support it with the tailstock, cover the rails and everything that could catch welding splatter, and add a few welds to fix it permanently. Unfortunately, I can't show you the welding process. First, it's not good for your eyes to look at the arc. And second, well, I possess the sacred welding technique, taught to me by the ancient monks of the Order of Welding, and I'm forbidden to share it with you under the threat of death. After welding, my welds look like this, already polished and perfect. I'm kidding, of course. I'm just a crappy welder, and this isn't the place for welding lessons. I'm still learning myself. So when it comes to welding, let's just say I can join two pieces of metal together well enough. Maybe the welds aren't the prettiest, but they hold. And that's what really matters. After finishing the welds, I also drilled a few holes for future fixation to the base and tapped a couple more for the screws that will hold the rod in place. And speaking of the rigid base, I think I finally found the right one. Something rigid enough. Maybe even a little too rigid. Now to the part responsible for moving the arm along the rod, up and down. I'm using these sliding bushings, kind of a linear plane bearings, lined with Teflon, and they move really smoothly. I had to machine the seats for them in the part left from the previous turning operation. I made the pockets a bit deeper since I want to install a dust shield later. Everything fits perfectly, no wobble, no unnecessary play. The only thing is the part slides a bit easier in the middle of the rod than at the ends. I guess that's why this rod ended up in a scrap pile. It has a bit of wear in the center, but it will totally work for my needs. Now to the lead screw. I also got this one from a scrapyard, but among all the parts I'm using in this build, this one is basically brand new. I want to dial it perfectly, so I'm using my big lathe and the 4-jaw chuck. Here is a bit of wisdom I've learned recently. When you dial in a lead screw, always dial it on the outer surface of the nut. That way, the nut's movement stays perfectly centered with the screw's rotation. Especially important if you're dealing with a ball screw. Nothing complicated here otherwise. I've machined the diameter to fit my worm gear and cut a slot to match the spline. I'm not cutting it to length yet. I will assemble everything first, then measure properly. So, from the lead screw, we move to the other side of the worm gear, where the motor sits, the input side. I am using a stepper motor for this. I will explain why later. For now, the shaft diameter of the motor and the bore in the worm gear are different, so I need to make a coupling sleeve. Inner diameter for the motor shaft, outer diameter for the worm gear. And now to finish the turning process, I need to make an adapter between the worm gear and the motor. I am using this old gear from my previous project, basically more scrap metal. The gear teeth are cemented, so hold on, it's gonna get a bit violent. In my defense, I'm just trying to reuse whatever left from rebuilding the lathe and other machines. Not the wisest choice, since cemented gears are hard to machine, but I'm using old inserts to break through the hardened layer, and then I will switch to a new one. Should be fine. Everything else here is pretty self-explanatory. I'm using the worm gear part as a drilling template to start the holes, then drill and tap them accordingly. And with that, we're done with the movement assembly. And now to the part I should have probably started with. You could say the whole purpose of this project is to give the new life to this old pantograph. But I was really hesitant to take it apart, even from the outside it was obvious how badly damaged it was. Sooner or later though, I had to figure out what kind of bearings I need to replace, well actually all of them, but I need to know which type and how many. And honestly, I haven't seen parts in this bad shape for a while. I mean, I don't even know what you have to do to shred bearing races into pieces. I even found one ball split in two. But it is what it is. I also need to remove the other part of the arm, since in this setup it's just in the way. But I want to keep as much of the original mechanism as possible, so I will turn this section on the lathe, just make it round. That way it will stay in place and still be part of the story. I think it's a good point to wrap up this part of the video. The bearings have arrived and I want to assemble the arm just to make sure they still fit in their places. As you remember, this part was really badly damaged. So now I will assemble everything, check how it works and order a few parts. But that's the story for the next video. Luckily, this assembly fits, well, not perfectly, but close enough. It has a little play in this direction, but overall it feels quite nice. I'm a bit worried about this pivot. It's a clever design if you need separate pieces rotating on the same axis. But I'm not sure how rigid it will be or how well it will suit my needs. I'll guess we'll see. Another joint assembled. These bearings are a bit loose. I can feel them wobble slightly in their seats. I think the material here is a bit worn out, so I should probably think about that maybe in the future get bearings with larger outer rays and bore these holes a few millimeters wider to get a proper press fit. But I'm not sure if there is enough material left for that. So maybe you guys can help. If you have any suggestions, please leave them in the comments. In general, the whole assembly feels rigid enough. I can't apply enough force to test it properly, but I'm happy with it for now. As I said in the beginning, we work quick and dirty and then test everything in action. That's it for now. Stay tuned for the next video. Meanwhile, thank you for watching. I'll see you soon.